Welcome to this EDUcast, solving unified communications and customer experience quality problems. With me today is Ross Williams, the Virsae Chief Success Officer, and I'm Gary Auden. As we always do, we're going to talk about our agenda. Why customer experience is really everything, symptoms of the problems you'll encounter, investigating the issues, and we're going to talk about manual approaches and then automatic approaches and how this can really affect the fast resolution of the problems you have out there. Most of the time we think of customer experience related to the contact center. With the significant growth of unified communications, customer experience has become very important there as well. You have a scale here. Where do you think most customer experiences fit in the scale of 1 to 10?
Well, I'd like to think that they are in the 9 and 10 area, Gary. This is actually a type of survey called a Net Promoter Score, or an NPS. And it's very common now that businesses that are running in a customer-facing sort of area, they run with an NPS. And the way it works is that actually any score that you get in the region of 1 to 6 is actually considered a score by detractors to your business or to your service. 7 and 8 is considered neutral, and 9 and 10 is considered positive. So in terms of an NPS and doing well in NPS, the benchmark is plus 40%. You have to get a lot of people in the 9 and 10 area. It's actually a very good way of assessing whether a customer is likely to stay with you and be loyal to your business and your brand or not. I imagine that in a lot of cases, a lot of businesses are actually falling short of getting into positive territory.
Would you take us through some of the symptoms and problems Virsae customers will encounter in trying to solve the quality problems?
You know, the main one really for interactions is the real-time nature of what we're doing now. So that includes both voice and video. And the main tip I would raise here is that if you are waiting for your customers to complain, it's already too late. So if you have full visibility of your contact center and your unified communications stack, you'll know ahead of time if there's any problems with those real-time interactions, those voice and video conversations that are so important to customer service and getting your services right for your end user. You know, in terms of investigating these problems, I've been around unified comms and contact centers literally for decades. And as an engineer, pattern detection was really the key to resolving a lot of these problems, you know, in the days when we worked through this manually. And that comparison of what group of factors, when they came together, constituted a good experience versus those group of factors that came together that produced a bad experience, that pattern was always the key to resolving these problems. Expertise in this area to do this, the type of engineering resource that's capable, is expensive and it's difficult to find, and it doesn't exist within most customers. With VSM and the introduction of machine learning and artificial intelligence, it really augments the power of your staff. So, you know, if you've got a couple of people that work in this sort of specialist area of IT on your unified comms and contact center area, you throw in some machine learning and artificial intelligence there, and it, you know, really empowers those people to do much, much more, because that pattern detection, that heavy lifting, that investigative work is all automated, you know, and effectively, you know, is a multiplier for your people. It makes it seem like you have a much, much bigger team than you do.
I see you're going to take us through the manual approach to problem solving. What does this slide represent for us?
This slide is a dashboard. In this particular case, it's looking at the SIP sessions that are going on within an environment. Now, SIP is the, you know, sort of the latest protocol to come out of unified comms and communications, and it's very, very widespread. And this dashboard shows what's going on from a SIP messaging performance. So these messages are very verbose, you know, and there's huge logs generated. So this is just a single session board controller. And in a 24-hour period, there's over 500,000 messages. So you can see that just, you know, having to troll through these and look through these logs manually is just absolutely impossible for a human to do.
Now, as we go to the next slide, this is a spreadsheet of information. What does it tell us?
This is digging down into those SIP messages. So on the earlier slide, there's like, you know, some sessions going on. So that could be voice or it could be video or text or other media. But digging into these, this is what we call a ladder diagram. So this maps out from the session border controller perspective what's going on in terms of that messaging. So who's saying what to whom? And even though this looks sort of pretty complex, you can dig down again into these and look at the underlying messages, and they are very, very verbose. So what we're saying here is there is a huge amount of data generated, even from relatively small sites.
This graphic represents measurements. As I'm looking at the pie charts, what are they? What does that mean to us?
And this one specifically is looking into the resulting quality of those sessions, so voice and video. And we're looking across literally tens of thousands of streams within customers, sometimes hundreds of thousands of daily streams of information, and the resulting call quality. So can the contact center agent, for example, can they hear and be heard clearly from the person they're talking to? And what we do with this particular dashboard is we're not only breaking that down and alerting IT staff to any problems if there are, but we're also doing a global comparison across our entire customer base. And we do that on an anonymous basis and feeding in where you sit within that. Are you in your environment producing world-class experience for your end users and for your customers?
As we continue, we have a term here. Help me understand, what does IPNR display mean?
IPNR is a technical term. It stands for IP network region. But basically it refers to a physical site. So that might be a single floor on a multi-story building, or it might be a particular branch out in your network somewhere. But it's a group of endpoints that people are using to communicate on, and they're grouped together based on a physical basis. And we can see here, digging down from that pie chart, digging further down into the information, an engineer doing this manually would be able to see when they use Virsae Service Management that in this case, in IP Network Region 5, that's where the vast majority of the poor experience is happening. So it's happening in one main location that has a problem.
How does this particular display relate to the call center then?
This is where we're marrying up the contact center agent with their endpoint, and that can be a difficult thing to do on the fly. So you've got to look at where your agents have logged in, because they can be working from home, they can be using a hot desk situation, so they can be quite mobile. So aligning where the contact center agent is actually sitting, what workstation they're sitting at, and what device they're using to communicate with has been resolved here. In the last little while, all of Bobby's interactions have only fallen into that satisfactory band.
As we move on now, we look at this. This slide represents a lot of information. What should I be learning from the green display area?
So the green is, again, on that, using the RAG, the red, amber, green. All the green experiences are considered good. So you can see Bobby's standing out there as amber. So what we're doing here is dig into one of those interactions that Bobby's had, and we're starting to get all the technical information. So we can see that IP addresses and so forth and codecs that are being used.
What are stream details?
Well, this is when we're really getting under the hood on that particular interaction. What we're looking at here is the performance of the network that's connecting the endpoint that the agent is logged into. So this breaks down the network performance into things like jitter, packet loss, and latency. So these are physical characteristics or performance characteristics of a network. There is no getting away from this. IP networks are not real time. It takes time to get packets across from A to B, and the various mix of circuits and equipment that's in that mix produces a varying amount of delay. So a lot of this sort of is born out of the latency side. And when you get latency, so it's how long it actually takes to get a signal from A to B. And it's particularly important for real-time conversations like voice and video, but it can even affect things like screen sharing. So you've got latency going on, which is, can produce problems for real-time applications. And when latency starts to vary, so sometimes, it's faster to get packets from A to B, and then other times it's slower, that generates a thing called jitter. And then, of course, there's packet loss as well, which is when the packets actually just don't make it from A to B at all, and you're kind of getting holes in your communication stream. So those three factors combine to produce a customer experience, which is mapped out along the bottom there. And we can see from that MOS, in that particular interaction, there was a regular reduction in the quality of that interaction.
Now, the next slide deals with configuration. All right, what can I learn from this configuration? What does it help me to deal with the problems?
So understanding how the network performs is one thing, but to get a true picture of what's going on, because networks are designed to prioritize different packets. And if you want to prioritize your packets, so reduce the latency on your network, you've got to have the configuration right at both ends, so both the sending end and the receiving end of a stream of data. So what VSM does here is it digs right down into we're getting right down into the very, very detailed configuration of either end of that stream. So we're able to pick out the configuration and the configuration, how it relates to that prioritization. So there's a lot of technical stuff on there that you can see, but things like DSCP, which is diff-serve tagging, is really important, as is a lot of the layer 2 stuff. So what we've done here with the VSM, it automates picking out all of that configuration information, which can be very difficult to extract from most people.
We're actually getting into the actual details of where the packets pass through. Is that correct?
That's right. That's showing where the packets go, and then the little triangle that's come up, that little red triangle, is indicating where there's a problem. So what was happening in the case of in this stream is in one direction, the diff-serve header is being removed. This is a relatively common problem when it comes to voice and video quality. Diff-serve's being removed, and we can see from this particular slide the most likely place that's happening. So we're pointing the finger at a particular layer 3 device. And the way we can tell that is that layer 3 device, there's a lot of latency around that.
Can you now take us over and talk through the automated approach to problem resolution?
Right. So what we've done, with VSM, Gary, is expose a lot of the information that people need to troubleshoot individual streams. And for a lot of organizations, that in itself is quite a major step forward, just having access to that information and being able to troubleshoot things manually. But with the use of machine learning and AI, and bear in mind here, what we're doing is simply looking for patterns. So while the engineer might use VSM to manually work through and resolve a problem like we've just seen, by using that machine learning capability, we can automate the detection of those patterns. What are the common areas that are causing problems? And that's the sort of thing that machine learning and artificial intelligence is just really, really good at. So what we've done here to demonstrate that is we've created an Alexa skill, which I can run on my mobile phone here. And we'll just give you an example of the sorts of things that we can do. So this skill runs against a real customer, so it's a real live environment. Alexa, run service management.
Welcome to service management.
How is my system health?
You are running 18 servers, with an average uptime of 99.99% over the last 30 days. Your longest outage was less than 5 minutes, and your average response time is 1.2 millisecond.
What is my peak current trunk utilization?
24 of 599 trunks are in use.
How is my voice quality now?
I detected 46 streams in progress. Currently, 0% of streams in progress have a MOS lower than 3.6.
What is the cause of my poor voice quality?
The majority of poor voice quality occurred where DSCP was stripped, where traffic was routed through IPNR 144, or through Layer 3 device 10.70.195.1.
You can do it from anywhere, but simply applying machine learning and picking up those patterns, it saves people from having to work through that that manual process of trying to resolve these problems. And having something like VSM, as you've seen earlier, even if you're doing it manually, it simplifies that process greatly by automating the presentation of a lot of that network performance and configuration data. But we've now taken it one step further, and giving a human voice to that machine learning and artificial intelligence via an Alexa skill.
We see the words speed of resolution here. What do you mean by that? And what does the data on the slide actually represent? Because it looks like huge numbers.
Yeah, so this is numbers are taken right across our install base, and this is growing very, very rapidly. Interestingly enough, Virsae over the last 12 months, so right through the COVID pandemic, we had more than 70 net new customers during that time period because a lot of people were having trouble with their customer experience, and we're able to shine a light on that and resolve those problems for them. So this is 1 month of Virsae service management in action. So we resolve around about 42 million events. So as events come up, we recognise the pattern, the signature to them, and there's automation to go in and resolve from a known action database. Over 500 million calls, and that's very typical for us. So we're heading towards 600 million call mark, which we'll get to very shortly. And there's 835,000 channels that we measure for capacity usage. So that's connections between customers and their telco service providers, and around about 70,000 contact centre queues, where we ensure that the customer experience is exactly what the contact centre management expect it to be. And then in the background, around about 1,000 documents per second are being created in our environment. So these are things like as-built network schematic diagrams, reports on performance and so forth. So you can see, it's a very, very big and very, very busy environment.
Take us through the Virsae service management platform and how it helps resolve these issues. And is this a cloud-based service?
Yeah, absolutely cloud-based, Gary. So we've been running for almost a decade now. We were cloud from day one. It's one of the cornerstone decisions that we made. So we're a cloud application. We run a DevOps approach to that, so there's continuous deployment going on in this environment. So what you get today is not necessarily what you'll have tomorrow. It will continue to get better and better and better. All of our customers around the world will enjoy those upgrades without having to take any of the traditional steps that you would have to in an enterprise environment of upgrading applications yourself and making sure you have adequate hardware and so forth. So VSM is just a cloud-based service. It's completely hands-off as far as our customers and partners are concerned. It just continues to evolve and update over a period of time. Down the bottom, we take a whole lot of feeds from different manufacturers, so the key players in the UC and contact center space, but more broadly than that as well. So cloud providers, even right down into details like headset, so telemetry data from headsets, all gets fed into that cloud environment where we have the artificial intelligence, machine learning, and data aggregation taking place. And there's different ways of consuming that data once we've done that. So the top left there, you can go through the VSM portal. We showed some slides and some dashboards from that earlier today. So you can use the traditional portal to consume that. Or in fact, you can use your own API if you want to feed any of that information through. If you wanted to do something like create your own Alexa skill or get Cortana involved, those APIs are there to do that. And we've got out-of-the-box integration through to the main ITSM players like ServiceNow, Splunk, Datadog, other players in that space can consume this specialized contact center and UC service management data.
Well, I'd like to invite people to contact you. Here's a website and their email and their contact information in various parts of the country. Thanks again for this very enlightening EDUcast, and I hope to be speaking to you and others in the future. Thank you, Ross.
Thanks for your time, Gary. It was a pleasure.